This drill bit has two cutting lips, but its heel can still hit first.
Then it rubs, makes heat, and barely cuts. 1-point angle is easy to print on a package. It cannot explain what happens behind the edge.
My name is Walt Kessler. On this channel, every claim has to survive a measurement or a source. You will learn that second check. We will inspect both lips, use a gauge, and walk through one controlled comparison as an illustration. If grinder safety is unresolved, the switch stays off.
Stay with me. By the end of this, you will be able to make the first inspection this weekend without turning on a grinder. Let me start with what most folks get wrong, because if you do not understand this, none of the rest will work. A drill point is not one angle. It is a small system of edges and surfaces. This episode is only about conventional two-flute twist drills. Masonry, brad point, step, spade, carbide tipped, and other specialty bits use different constructions or geometries and stay outside this method. Now for the first half of the controlled illustration. A real before run and after run would use the same ordinary twist drill, the same material stock, and the same recorded drilling setup. The workpiece would be secured. The drill, speed setting, hole start, operator, feed method, cooling interval, and inspection method would stay fixed. This illustration is not a test of every drill, every steel, or long-term service life. It shows the checkpoints and their narrow limits. In the first illustrated run, look at how readily the bit starts, whether it appears to rub before it feeds, what the chips might look like, and what the finished hole might look like. That gives us the before condition to inspect. It does not yet tell us why. Look straight at the tip. The two cutting lips run outward from the center. Between them is the chisel edge. The chisel edge sits near the center and pushes more than it cuts. It is not one of the two main cutting lips. Now turn the bit sideways. The angle formed by the two main cutting lips is the included point angle. For many common general-purpose twist drills, published guidance uses 118 degrees included. That is 59 degrees on each side. Those numbers describe the point. They do not describe the space behind the cutting edge. That space comes from lip clearance, which is also called relief. The surface behind each cutting lip must fall away enough that the edge can meet the work without the heel rubbing first.
That is the second angle. A single number is easy to package and sell as certainty. The cutting edge does not care how neat the label looks.
Material, bit size, construction, and the maker's guidance can call for different geometry. 118 degrees is a common general-purpose example. It is not a universal command for every drill. The second angle is harder to see, so people often ignore it. Too little clearance can let the heel rub and generate heat instead of useful cutting. Too much clearance is not a free improvement. It leaves less support behind the cutting lip and can weaken the edge. That gives us the first useful rule. Do not chase the largest clearance you can grind. Look for enough relief to clear the work while keeping support behind the cutting edge. Published guides do not all state the same clearance range. The Army General Purpose Guidance gives roughly 8 to 12 degrees. The Tormek attachment gives roughly 7 to 14 degrees depending on bit size and the material being drilled. Those ranges are source-specific. They are not permission to force every bit into one number. We are not guessing from the silhouette. We are measuring what the cutting geometry is trying to do. Here is the inspection with no machine running. First, clean the tip well enough to see the two lips. Use bright, steady light. Keep the bit cool and handle it as though it may still be hot if it has just been used. Second, look straight down the point. Compare the two lip lengths from the center toward the outside corners. They should be equal enough that one lip is not being asked to do most of the work. Third, look at the center. If the lips are unequal, the chisel edge can shift away from center. A point can still look tidy from one side while the two cutting edges are sharing the job unevenly. Fourth, place the point against a truthful gauge. For this common general purpose example, the gauge shows 118 degrees included, or 59 degrees on each side. It tells you whether the two sides are meeting the selected point geometry symmetrically. The gauge does not certify the clearance behind the lips, the condition of the steel, or the suitability of that geometry for every material. Fifth, rotate the bit and inspect the surface directly behind each cutting lip. The cutting edge should stand proud of the heel in the direction the bit turns. If the heel meets first, the cutting lip cannot do its work cleanly. This is the second angle again. Point angle tells you where the two lips meet. Clearance tells you whether each lip has room to cut. Now we have three separate questions. Is the included point angle suitable for this ordinary bit and the material in front of it? Are the two lips equal and meeting near the center? Does each lip have enough clearance behind it without being left thin and fragile? A yes to one question does not answer the other two. That is why a bit can pass a quick side view and still wander, chatter, rub, or make a poor hole. Those symptoms can also have other causes. Heat alone does not prove the point angle is wrong. Drill speed, feed, material, damage, construction, and the rest of the setup still matter. Here is one hand sharpening mistake. One lip receives a little more grinding than the other. The point angle may still look familiar, but the lips are no longer equal. The longer lip can dominate the cut, and the hole can become oversized or uneven. The correction is not to keep grinding faster. Stop. Cool the situation safely. Inspect from the front. Compare both lips. Remove only what the measured geometry calls for. If you cannot see the edge clearly, cannot hold the bit securely, or cannot repeat the motion without forcing it, the job has already given you the answer. Stop and use a proper jig, a suitable sharpening service, or a replacement bit. I would rather you trust the limit than be impressed by a shower of sparks. A gauge can show how the geometry lines up. It cannot promise factory geometry, original heat treatment, hidden structural safety, or a like new bit. A damaged or uncertain bit earns a stop, not a more dramatic grind. The Army Guide treats a blue cutting edge as an overheating warning. Color alone does not reveal the remaining hardness or prove that a bit is safe to restore. If overheating, cracking, bending, deep chipping, or unknown construction is part of the story, stop. Now, the grinder boundary. The exact machine and wheel manual control the setup. Guards stay installed. The grinder must be firmly mounted. The wheel must be sound, compatible with the machine, and rated for the spindle speed. The work rest and guard openings are checked while the machine is unplugged and fully stopped. The maker's stricter limit wins. Wear certified safety glasses with side protection. A machine eye shield is not a substitute. If you are not trained on this exact grinder, stop. Secure long hair and loose clothing. Remove jewelry. Do not operate around flammable liquids, gases, or dust, and keep bystanders clear. Do not stand in line with the wheel during the startup check required by the exact manual. Do not grind on the side of an ordinary wheel. Do not jam the work or force a wheel that is slowing down. Small bits create their own problem. If the bit is too small to hold securely while keeping fingers safely clear, stop. No video deadline is worth asking fingertips to work beside an abrasive wheel. Treat the bit as hot and do not test it with bare skin. Do not grind it until it is seriously overheated and then plunge it into cold water or coolant. The Army Guide warns that this can crack the lip.
If any one of those conditions is unresolved, the demonstration ends before the switch moves.
Then inspect the bit again. The point gauge checks both sides of the included angle. The straight-on view checks the lip lengths and the position of the chisel edge. The side view checks whether each heel falls away behind its cutting lip. In this illustrated sequence, every safety condition has passed before the bit is supported on the work rest and touches only the intended wheel face. A trained operator uses light, smooth contact, stops between passes, and compares point angle, lip length, and clearance again. If the wheel slows, the grip changes, the bit seriously overheats, or the geometry cannot be judged, contact stops. Only then would a second run begin. Now compare the two illustrated runs. If a real second run were cleaner or easier, the narrow conclusion would be that better measured geometry improved that example under those conditions. It would not prove that every bit needs the same angle or that the bit is restored like new. If a real second run did not improve, that result should stay in the video. It would mean the bit or setup needs a different diagnosis. Failure is evidence when you do not edit it away. That is the second angle for the third time. First check where the lips meet. Then check whether the surfaces behind them get out of the way. Finally, check whether both lips are doing equal work.
Guessing looks at the point and sees sharp. Measuring asks three better questions and accepts stop as a valid answer.
Here's your assignment for this weekend. Start with one conventional two-flute twist drill you already own. Do not turn on a grinder. Put the point under bright light. Identify the two cutting lips and the center chisel edge. Compare the lip lengths from straight on. Use a truthful gauge if you have one, then inspect the clearance behind both lips. Write down one decision, suitable for a controlled setup, needs a proper jig or qualified sharpening service, or damaged and better replaced. No purchase is required to make that first inspection. The deadline is this weekend, and the safe answer may be to stop. Which problem did you find first? The point angle, the clearance behind the lip, or unequal lips? Tell me which of those three you saw. I read every one of these. Next time, a water heater, a long metal rod, and one measurement. The question is whether that measurement can tell us anything useful.
Measure it before you replace it. Most things are not broken. They are just out of adjustment.